The first serious proposal for a ship designed to travel underwater was made by the English mathematician William Bourne in 1578. Bourne suggested using two hulls, one of wood and one of leather, but this device was never actually built. The first working submarine was built by the Dutch inventor Cornelis Drebbel in 1620. Using a design similar to the one proposed by Bourne, this device was propelled beneath the surface of the Thames River by 8 wooden oars. During the early 18th century, several small submarines were built using similar designs. In 1747, an unknown inventor suggested attaching goatskin bags to a submarine. Filling the bags with water would lower the submarine, and ejecting water from the bags would raise it. The same basic concept is used in modern ballast tanks. The submarine was first used in warfare during the American Revolution. The Turtle, designed by Yale student David Bushnell, attempted to attach an explosive to a British warship, but failed to penetrate the copper sheathing on the ship's hull. In 1801, the American inventor Robert Fulton built the Nautilus, a submarine constructed of copper sheets over iron ribs. The Nautilus, which could carry a crew of 4, succeeded in sinking ships in tests, but was rejected by both France and England. Fulton was working on a steam-powered submarine that could carry a crew of 100 when he died in 1815. During the American Civil War, Horace L. Hunley financed the building of submarines for the Confederacy. The third of these vessels, the H.L. Hunley, attacked and sank the Union ship Housatonic on February 17, 1864, but was itself destroyed in the resulting explosion. During the late 19th century, numerous submarines were built in the United States and Europe. Methods of moving the submarine evolved from hand-operated propellers to steam engines, gasoline engines, and electric motors. Submarines using diesel engines for surface travel and electric batteries for underwater travel were used successfully in World War I and II. The development of nuclear power after World War II revolutionized submarine technology. Under the direction of Hyman Rickover, an engineer and officer in the U.S. Navy, American inventors Ross Gunn and Philip Abelson designed the Nautilus, the first nuclear submarine that was launched in 1954. By 1959, some nuclear submarines, known as strategic submarines, were used to carry missiles with nuclear warheads. Other nuclear submarines, known as attack submarines, were designed to sink enemy ships and submarines. Strategic submarines and attack submarines became a vital part of naval forces worldwide. The first use of a nuclear submarine in active combat took place in 1982, when the British attack submarine Conqueror sank the Argentine ship General Belgrano during the conflict over the Falkland Islands. Robert Fulton, best known for his work in steamboat technology, was born in Little Britain, Pennsylvania, in 1765. As a child, Fulton enjoyed building mechanical devices. His interest turned to art as he matured, and although he managed to support himself through his sales of portraits and technical drawings, the general response his work received was disappointing, and convinced him to concentrate on his engineering skills. In 1797, while researching canals in Paris, France, Robert Fulton became fascinated with the notion of a plunging boat, or submarine, and began designing one based on the ideas of American inventor David Bushnell. Fulton approached the French government, then at war with England, with the suggestion that his submarine could be used to place powder mines on the bottom of British warships. After some persuasion, the French agreed to fund the development of the boats, and, in 1800, Fulton launched the first submarine, the Nautilus, at Rouen. The 24.5 feet (7.5 meters) long oval-shaped vessel sailed above the water like a normal ship, but the mast and sail could be laid flat against the deck when the craft was submerged to a depth of 25 feet (7.6 meters) by filling its hollow metal keel with water. Fulton's plan was to hammer a spike from the metal conning tower into the bottom of a targeted ship. A time-released mine attached to the spike was designed to explode once the submarine was out of range. Although the system worked in the trials, British warships were much faster than the sloop used in the experiments, and thus managed to elude the slower submarine. The French stopped funding the project after the failed battle attempt, but the British, who considered the technology promising, brought Fulton over to their side. Unfortunately, once again the submarine worked well in tests, but proved unsatisfactory on practical situations. After his failure in the Battle of Trafalgar, 1805, the British too abandoned the project. After these experiences, through his contacts in Paris, Fulton met Robert Livingston, 1746–1813, the American foreign minister to France who also owned a 20-year monopoly on steam navigation in New York State. In 1802, the two decided to form a business partnership. The following year, they launched a steamboat on the Seine River that was based on the design of fellow American John Fitch. Fulton returned to New York later in 1803 to continue developing his designs. After 4 years of work, Fulton launched the Clermont, a steam-powered vessel with a speed of nearly 5 miles per hour. The partnership between Fulton and Livingston thrived, and Fulton had at last achieved a recognized success. Fulton's persistence and belief in his ideas helped steamboats become a major source of transportation on the rivers in the United States, and resulted in a significant reduction of domestic shipping costs. The main material used in manufacturing a nuclear submarine is steel. Steel is used to make the inner hull that contains the crew and all the inner workings of the submarine, and the outer hull. Between the two hulls are the ballast tanks, which take in water to make the submarine sink and eject water to make the submarine rise. In addition to steel, various parts of a nuclear submarine are made from other metals, such as copper, aluminum, and brass. Other materials used to manufacture the thousands of components which make up a fully equipped nuclear submarine include glass and plastic. Electronic equipment includes semiconductors such as silicon and germanium. The nuclear reactor that powers the submarine depends on uranium or some other radioactive element as a source of energy. A nuclear submarine is a ship powered by atomic energy that travels primarily underwater, but also on the surface of the ocean. Previously, conventional submarines used diesel engines that required air for moving on the surface of the water, and battery-powered electric motors for moving beneath it. The limited lifetime of electric batteries meant that even the most advanced conventional submarine could only remain submerged for a few days at slow speed, and only a few hours at top speed. On the other hand, nuclear submarines can remain underwater for several months. This ability, combined with advanced weapons technology, makes nuclear submarines one of the most useful warships ever built. Because nuclear submarines are only manufactured for military use, the decision to build them is made by a national government. In the United States, the Undersea Warfare Division of the Navy is responsible for requesting that a group of submarines, known as a flight, be manufactured. The Navy accepts bids from thousands of companies to manufacture the many components which make up a nuclear submarine. The hull of the submarine is generally made by the Electric Boat Division of the General Dynamics Corporation. The original Electric Boat Company made the first submarines used by the United States Navy in 1900. Funding for nuclear submarines is included in the defense budget presented by the President to Congress. If approved, the manufacturing process begins. The nuclear reactor is supplied by the government's Naval Reactor Project. The methods used to manufacture these nuclear reactors are closely guarded, and disclosure would be considered a breach of national security. The greatest concern dealing with wastes produced by nuclear submarines involves the radioactive waste produced by nuclear reactors. Although the waste produced by a nuclear submarine is much less than that produced by a larger nuclear power plant, similar problems of disposal exist. The Naval Reactors Program has an excellent record of safely storing radioactive wastes. Some environmentalists, however, have expressed concern about the possibility of radioactive material being released if a nuclear submarine is sunk by accident or during military operations. Nuclear submarines are expected to remain a vital part of naval defense systems for many years to come. Future designs will feature new ways to improve the speed and depth capabilities of nuclear submarines. Research will also lead to an improved ability to detect enemy ships while remaining undetected. With the demise of the Soviet Union, leading to reduced defense budgets, the US Navy faces the challenge of reducing the cost of nuclear submarines while retaining their effectiveness. With this goal in mind, the new attack submarine program was devised in the 1990s, with the goal of replacing large and expensive Seawolf attack submarines with smaller, less expensive, yet equally effective nuclear submarines.